Aha, here we go. Hello there. Thanks for tuning to Excel Island and welcome to my live stream. My name is Abatan Sheriffdeen and I'm a top rated plus freelance data analyst. I'm a full-time freelancer and this is my first year of becoming a full-time freelancer. At this time last year, I was working on a 9 to 5 job, also freelancing part-time. But this year, 2023, I decided to become a full-time freelancer, 100% full-time working from home. And that's been really, really amazing and, of course, challenging. Probably by the beginning of the next year, I'll share some insight how I was able to navigate becoming a full-time freelancer. So basically, what I do on this channel is I've been live streaming my learning journey using the Datacamp platform for the past 44 days. Today is day 44, and the idea is to be consistent with learning. So I'm trying to upskill myself. I'm actually top rated plus on the upper platform. I've had major success on the platform, and this has been to the fact that I have a coach who has been teaching me one or two things, or almost everything I know about freelancing for the past 2, 3, 4 years, getting close to 4 years now. So his name is Bengadebi, and he has a course currently listed on the seller platform. And the name of the course is Freelance Client Magnet Course, which teaches you how to become a successful freelancer like I am, and enjoy the freelancing business and have a successful freelancing business. I'll leave a link to the course in the description. Do make sure to check it out. So the course teaches you all you need to know about Upwork, Fiverr, LinkedIn, your website, and even using your social media and optimizing your social media for gigs and clients, like using your social media for freelancing business. Do check out the course by Bengali. I'll also leave a link to Bengali Twitter accounts so you can check out Bengali. Let me show you real quick what Bengali look like. I'll go to Twitter and search for Bengali. He's a highly top-rated coach. So he has coached a lot of successful freelancers. Do make sure to check out his pin tweet. You see a whole lot of testimonials in his pin tweet. So back to my data camp. So I've been learning consistently on data camp for the last 43 days, and the goal is 100 days learning streak. So the goal is to achieve the 100-day learning streak without missing a day. So I've been learning 35 minutes, 30 minutes, 45 minutes, 1 hour every day without missing a single day. And it has been really challenging, and it tweaks my body. I kind of find ways to be energetic, do exercise, and do a lot of stuff just to be consistent with it. Even if I decide not to be consistent, at the at the end of the 100 days, at the end of the day, the 100 days will be complete. And what have I achieved? So the idea is to be consistent and make sure part of the 100 days, within these 100 days, if I'm counting 1 to 100, I should have achieved something, no matter how little it is. So I'm on the career tracks of the Datacamp platform. I want to show you what it looks like. So this is the career track. It has data analyst, data science, data engineering, programmer, machine learning scientist, statistician. But if I select the whole track, I can just select data analyst, but let's select the whole track. So I'm using the data analyst in SQL track here. And there are also data analysts. I'm coming back to after completing data analysis in SQL. My goal is to jump to data analyst in Power BI and also complete that track also. So the track contains 11 courses, and these courses is over 39 hours of courses with a certification, with a project. There's a project in the course track rather, and there is a certification in part of the course also. So you have to pass the certification to be data camp satisfied. So I want to show you what it looks like. So out of the 11 courses, I've completed 5 courses in this track. So I'm on this sixth course currently. So I should complete the sixth course. I'm almost through with you can see it data analyst in SQL comes with a certification. It's 39 hours. Obviously, you spend more hours, more than 39 hours. It has 11 courses with one project. I've completed 5 courses so far, almost on the sixth course. So almost about to complete the sixth course. So we have like 5 more courses to go with the project and statement of accomplishment, which is just a certificate, and there's a certification also. So that's that. So I'll just go back to the learning dashboard and let's finish this chapter. Then we'll move to the next one. So if you're looking to start your own tech business also, your freelancing career also, your tech career also in data analytics, I'll leave a link to the Datacamp platform in the YouTube description. You can check it out. They have a couple of free courses, but to have full access to the platform, you have to pay a subscription. But today I kind of jump upon a, a resource, a cool free resource by Jonathan Smith. You can Google Jonathan Smith on LinkedIn. He has a free resource about data analysis, a roadmap for data analytics. I would have loved to show you what it looks like right now. But you can just go to LinkedIn and search Jonathan Smith, the roadmap to data analytics. He has a whole lot of resources there. He compiled a whole lot of resources while collaborating with top data data gurus in data space, and they came together and compiled a very comprehensive data analytics resources. So you can check it out on LinkedIn. So let's finish this part of the course. So I'm on the last chapter of the course. I'm on the last chapter of the course of this chapter. Sorry, yeah, I'm on the last chapter of this course, which is functions for manipulating data in PostgreSQL. So I was able to do a couple of text. This is full text search and PostgreSQL extension. So I did all this yesterday. So the goal is to finish it today and move to the next course in the track tomorrow. So let's finish this today. So I have my slide open on my second screen. So let's finish this section of the course.
You've learned how basic full-text search is a better option when searching text data for a string. Next, we're going to learn about some common extensions, fuzzy string match and PGTRGM, that enhance the full-text search capabilities of PostgreSQL. But first, we will learn about the PostgreSQL extension framework in more detail. Most PostgreSQL distributions come bundled with a common set of widely used and supported extensions from the community that can be used by simply enabling them. Here are a few common extensions. PostGIS adds support for allowing location queries to be run in SQL. PostPick allows for... You've learned how basic full-text search is a better option when searching text data for a string. Next, we're going to learn about some common extensions, fuzzy string match and PGTRGM, that enhance the full-text search capabilities of PostgreSQL. But first, we will learn about the PostgreSQL extension framework in more detail. Most PostgreSQL distributions come bundled with a common set of widely used and supported extensions from the community that can be used by simply enabling them. Here are a few common extensions. PostGIS adds support for allowing location queries to be run in SQL. PostPick allows for image processing within the database. Fuzzy string match and PGTRGM provide functions that extend full-text search capabilities by finding similarities between strings. To help you discover what extensions are available in your specific PostgreSQL distribution, you can query the PG Available Extensions System view, as shown in this example, to determine a list of extensions that are available to be installed and enabled for use.
Select name from PG Available _ extension. DB link, register statement. Okay.
The results return the name of the first two available extensions. A similar query of the PG Extension System table will tell you which extensions have already been enabled in your database and are currently available for your use. Here we see only one result, the extension PLPG SQL. Any of the extensions that are returned from the PG Available Extensions System view can be loaded into your database and enabled with a simple query using the creates extension command, an example of which is PG Available Extensions System view can be loaded into your database and enabled with a simple query using the creates extension command. Any of the extensions that are returned from the PG Available Extensions System view can be loaded into your database and enabled with a simple query using the creates extension command, an example of which is shown here. The if not exists command can be used to ensure that if the extension has previously been enabled, the query will not generate an error message. Now, if we query the PG extension table again by selecting the ext name column for all records, we should see that fuzzy string match is now listed with PLPG SQL. When performing a full-text search based on user input or looking to perform an analysis and comparison of text data in a natural language processing exercise, a function that you will use often is Levenstein from the fuzzy string match extension. The Levenstein function calculates the Levenstein distance between two. When performing a full-text search based on user input or looking to perform an analysis and comparison of text data in a natural language processing exercise, a function that you will use often is Levenstein from the fuzzy string match extension. The Levenstein function calculates the Levenstein distance between two strings, which is the number of edits required for the strings to be a perfect match. In this example, you see the distance returned is 2, because in order to convert gumbo to gambol, it would require replacing the U with an A and adding an L to the end of the word, or 2 edits.
Okay.
For the strings text data in the ext name column for all records, we should see that fuzzy string match is now listed with PLPG SQL. When performing a full-text search based on user input or looking to perform an analysis and comparison of text data in a natural language processing exercise, a function that you will use often is Levenstein from the fuzzy string match extension. The Levenstein function calculates the Levenstein distance between two strings, which is the number of edits required for the strings to be a perfect match. In this example, you see the distance returned is 2, because in order to convert gumbo to gambol, it would require replacing the U with an A and adding an L to the end of the word, or 2 edits. The PGTRGM extension provides functions and operators to determine the similarity of two strings using trigram matching. Trigrams are groups of 3 consecutive characters in a string, and based on the number of matching trigrams in two strings, will provide a measurement of how similar they are. This measurement can be calculated using the similarity function of this extension. The similarity function accepts 2 parameters, the first being the trigrams in two. The PGTRGM extension provides functions and operators to determine the similarity of two strings using trigram matching. Trigrams are groups of 3 consecutive characters in a string, and based on the number of matching trigrams in two strings, will provide a measurement of how similar they are. This measurement can be calculated using the similarity function of this extension. The similarity function accepts 2 parameters, the first being the string you wish to compare, and the second being the string you wish to compare against. This function will return a number between 0 and 1, with 0 representing no matching trigrams at all, and 1 representing a perfect match. In this example, we see that using similarity on gumbo and gambol returns a value of 0.18 repeating. Great job! Let's practice.
Let's practice. So, before you can use the capabilities of an extension, it must be enabled. As we have previously learned, most PostgreSQL distributions come pre-bundled with many full useful extensions. How's that? So come pre-bundled with many useful extensions to help extend the native features of your database. You will be working with fuzzy string match and PGTLGM in the upcoming exercise. But before you can practice using these capabilities of this extension, you need to first make sure they are enabled in your database. In this exercise, you enable the PGTLGM extension and confirm that the fuzzy string match extension, which was enabled in the video, is still enabled by querying the PG extension system. So this says enable the PG3RGM extension. So PG3RGM extension, let's say enable, create if not exist, you can use this create extension syntax there. Okay, create extension if not exist, PGL not to create the PGL underscore TGM. You can run the code, let's see. So we just submit it. We just create syntax. To select all rows extension. Now confirm that both fuzzy string match and PGL stream are enabled by selecting all rows from the appropriate system available. I want to see if they are enabled. Select all rows. You can select name. You can just select star. Let's start from. You confirm that both of them are enabled. Okay, extension. You can just say PG extensions or PG available extension. I want to see those that have been installed. So PG extension. All that. So as you use select extend name. Aha, so we have them. What do you mean create again? I don't have to use create extension again. So PPO fuzzy match PGTRGM. We have created it in the last video now. We have to use this. Let's use create extension explain if not exist we are going to create fuzzy let's see if it's going to work now. 60. So we got that. That's pretty straightforward. Now select the film table and description. Calculate the similarity between the title and description. So select the film table. Okay, film. Select the film title and description. So the film title and the description. Calculate the similarity. You can use leaving string there between them. Levinstein, that's Levinstein for title and description column. Confirm on that. Select star. What do you mean select star? It's supposed to return automation spelling Levinstein very well. Spelled correctly. And let's see that Celesta way. How are you expecting Celesta here? What's wrong with the Datacamp platform? What is wrong with the Datacamp platform now? You're asking me to select title and description columns. You're giving me another result. Now that you have never filled in, you can begin the expression. First, we will measure the similarity between the title and description from the same table or the circular database. Why not asking me to put Celesta here? I don't know what's wrong with the platform these days. And it's not fair. Let me send them some feedback. What's the challenge? Currently to select star here when this function says select the title. This is not fair. Let me just follow the instruction. That will be wrong. It says select the title and description columns. Let me close it and start. I will start it again. I don't know what's wrong with the platform these days. Maybe third time or fourth time this is happening. Okay, yeah, let's do it correctly this time around. Select title. So we are supposed to use the similarity. Oh, so Levinstein will give us another source. So similarity should give us the result that we want. Yeah, but it's not giving us the similarity that we want. Let's see. Now that was very to this stop. So select the film table and film description, the film title, the title of the film, and the description. Calculate the Levinstein distance. Oh, I want to calculate the Levinstein distance. We can use our Levinstein function there. From the film title, okay, title with the string jet neighbor. To calculate the Levinstein distance for the film title with the string jet neighbor. What do you want to calculate? Oh, with the string title. So what film do you want to calculate it? We use with the string jet neighbor. So I calculate with a string called jet neighbor. What is our other string? Calculate the Levinstein distance for the film title with a string jet neighbor. What is now our second argument here? So with what string are we calculating that? Jet, is it with the string jet and neighbor? I guess it's with the string jet and neighbor. Let's see. Let's see that in action. Why was the challenge now? So I'm reading this now. Take a closer look at how we can use the Levinstein function to match string against text data. If you recall, the Levinstein distance represents the number of edits required to convert one string to another string being compared in a start application or when performing data analysis on any data that contains manual user inputs. You will always want to account for typos or incorrect spellings. So the Levinstein function provides a great method for performing this task. In this exercise, we perform a query against the film table using a search string with a misspelling and use the results from Levinstein to determine a match. Let's check it out. Oh, there's a misspelling here, jet neighbor. Okay. Probably it's good to always read the instruction first before performing. There's a misspelling here. I just have to spell that correctly. Probably use Neigbour. Let's see if that is going to work. What's the other by doing here now? That's two. Let's comment other buyouts and list several results. This one isn't Levinstein. What are we having? This is not funny. So we want to only calculate Levinstein distance. why are we having select title here all over again? If I comment all this out, probably run this code. Let's see if that's going to be correct. We also have my select clause there. Okay. C is 1, but it's not going to accept the answer. Since we only need to correct the U here to this. If I reset the code now, the instruction says select title and description column. You selected the title and description column. Calculate the Levinstein distance. I'll just copy this one from you. So that's the function we want to use. So calculate the Levinstein distance for the film title with the string jet neighbor. Film title with the string jet neighbor. I can't start looking at for it like that. Let's see, I'm still going to get an error. I don't know what the other by clause is doing here. Other by theory, which is Levinstein. I see the distance there. The distance is there. Let me off my camera quickly. Consider the distance between those four there. They already need by this distance there. This is just 1, 1, 1, 1, 1. It's kind of challenging though. I don't know why. Let's take a hint. So, okay. My mistake is from here. The column film title. But when we're using Levinstein, it's comparing just two characters. Let's say the title column and the keyword this um, I don't accepting the results. Select film title and description. Calculate the Levinstein, which has been calculated, but the answer is not being accepted. I don't know why. There's no code highlighted there now. Let me copy that. Let me just paste that back. I'm pretty sure that is the correct answer. I don't know why that is not correct. Yeah, let me just close this one more time and do it again. Okay, you're still getting same error. This is not fair. Let me continue. Let me call this and let me click on show answer. Oh, mistake was I was quoting the title column. I was putting asterisks on the title column. Hmm. That's not fair. Because the example that I was giving, when they were using Levinstein, this formula, they were comparing two test strings, Gumbo and Gambo. So I can actually compare. It says the Levinstein function requires two parameters, the text, data, or column that you wish to search, and the start string, get neighbor. Uh, just wonder whether it is different from what we had earlier. Oh, get neighbors. This answer is one. Hmm. Okay, we can see the distance. Let me show you quick. So the distance there is one ordered by three, ordering by three, which is 1, 6, 7, 8, 9. So the distance is quite different. The title column and the text string get neighbors, which is one because jet here, the jet neighbor is missing one letter, which is U. Jet neighbors. The neighbor is not spelled correctly though. So it's not having one letter. U neighbors. This one is having six distance. And this one should be the number of letters missing there. Let's see. CHBOURS. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. Why is not 6? I'm trying to figure out the count, the distance here. 6, 1. So it's probably 1. Jet, NEIGHBOUR. Hmm. It says 11, so very good method. Right. Number of edits required to convert one string to another string. Compared, being compared. So title here. To convert title to I'm trying to understand this function pretty well again. This Levinstein function. Mm. So Levinstein function. Okay. In this use case, I'm trying to understand the use case here. So using for this Levinstein, the title or column and the search we use to compare with, which is get neighbor. Next we get neighbors compared with title. Distance of 1. from a distance of 6 EU neighbors. Hmm. I want to understand how they come about this calculation of the distance. 1, 6, 7, and so on. Oh, okay, I guess this is best neighbor. 1, 2, 3, 4, 5. This is way before 6. If I look at this one, it's saying 6. Oh, hmm. I mean, the explanation in the video is not well explained. I'll probably need to figure it out. I could just use Google though. I could just Google it and say, let's copy this. I could just Google this. Let's give the real quick Googling. Let me read this blog. I think I kind of find this useful. This is kind of going deeper and deeper. This is not quite simple to understand. Okay. Can we repeat the explanation here? We just put in SQL there. Let's look at Stack Overflow. I'm kind of curious. I just want to get a good understanding of this Levinstein before leaving. Okay, let's see. Hmm. This kind of jam packed. Look at this example on Datacamp. It's still on Datacamp. Wait, this I want to look for it in use another explanation to explain it better. I want to use another explanation entirely. I don't use Datacamp. Let me read this doc. I saw a free code camp. Last time I had issues like that, I was doing a free code camp. Kind of saw, I think I'm seeing, for example, free code camp. Kind of like free code camp resources. They will explain better. How to use fully string matching with PostgreSQL. Okay, let's see. To fact, people make typos or people use alternative spelling on a frequent basis. Whatever the case, from a particular point of view, different variants of similar string can pose challenges for software developers. The application needs to be capable of handling these inevitable edge cases. Take me, for example. I got Peter in some places, Pete in others, among other variants. My name can be represented by Pete, Gleason Peter, MP Gleason Peter. Okay. Mm, so using similarity. From after that, I'm going to see after. So you say the name. Okay, similarity. Also reference the column. Why is it similarity? Oh. So we're using similarity for two text string. Calculate a column. Okay. Using match. Mm. So see below for a query which find. I think this example, this is the explanation I need there. I'll have to come back to this explanation because the blog is kind of long. I have to read it later on my own off live stream. So let me just submit this and try to get a good understanding of that later. Okay, let's continue. I'll probably use the article to read it. So select the title and description for all the videos on the same table. Title and description are selected. Where perform a full text search by converting the description to a TS vector and match it to the phrase outstanding and drama using a TS query in the where clause. Oh, okay. I also convert it to a TS vector to query. Oh, okay. So select. So okay, you need to create a test vector from the description column in the film table. So that will be TS vector here. So in this exercise, we are going to use many of the techniques and concepts we learned throughout the course to generate a data set that we could use to predict whether the words and phrases used to describe a film have an impact on the number of rentals. First, you need to create a TS vector. Okay, TS vector from the description column in the film table. You will match it against TS query to determine if the phrase outstanding drama leads to more rentals per month. Next, create a new column using the similarity function to run the film description based on the phrase. So that will be to, I think is the at sign there. So okay, set it to TS vector here, to TS vector underscore that, so to TS vector at, so now let's see what it's giving us there. Just converting, so the TS vector, what it's doing is this, determine if the phrase outstanding drama leads to more rentals per month. Then you have to use, so the result by a new similarity column. Okay, also use similarity here. Add a new column to calculate the similarity of description with the phrase outstanding. So I use similarity here. Just go and say similarity, similarity, description column, description to the keyword outstanding, outstanding drama here. So if I just order by this, I just copy the whole of this and just paste it there. Let's calculate the similarity and boom. That was straightforward though. So the similarity is, let me show you what it, let me just off my camera there so you can see that. So similarity is 0.2, not close to 0.1. So what this is doing, where to TS vector description is converted to TS square outstanding drama. Okay, where we have, so I think for where we have the keyword outstanding drama in our description. I think this is what display we have here. So we're now comparing the similarity of the description to the keyword outstanding drama. And what the similarity does, similarity, let's just use how similar those words are. Okay, we're having 0.2, 0.19. Okay, okay. I think this will need more practice. So putting it all together, let's see.
Let's review what we learned in this course. First, you learned about common data types, including strings, numerics, and arrays. You learned about arrays and their special characteristics and how to use arrays to store lists of data and access and search elements in the list. Next, you learned how to manipulate and query date and time objects, including how to use the current timestamp in your queries, extract subfields from existing date and time fields, and what to expect when you perform date and time arithmetic. You learned how to manipulate string and text data by transforming case, parsing and truncating text, and extracting substrings from larger strings. And finally, you learned about how to extend PostgreSQL capabilities using extensions and explored full text search using the extensions Fuzzy String Match and PG TRGM. Everything you learned in this course will be foundational in your day-to-day work with PostgreSQL. The functions you learned about will be used again and again as you use SQL to manipulate, extract, and transform data from PostgreSQL databases. If you'd like to continue learning about PostgreSQL, I encourage you to look at the official PostgreSQL website, which contains all official documentation, official source code downloads, and installation files, as well as a community of users ready to help.
That's true. Then we come to the end of the course.
As well as a community of users ready to help.
All right. Let's take that function looks like. No need yet. Only for this. The most important thing is to practice, practice, practice. Let's continue to the dashboard. Yeah, we consistent for the last 46 days, 44 days rather. We've completed 6 courses, 1 trial completed. Not bad. Let's go back to the dashboard. I'm still coming back to this. Come on, look quick. No, probably because I've completed half of the course. So I'm halfway through the course. That's why. I'm waiting for this to load. So So this is not coming up, but that is the end of the live stream. So I'll continue from a new course entirely. I think the next course is data analysis in SQL. So okay, hold up. Let me see. Uh-oh. Let me see what I've done. Completed. Let me go to the career tracks and see that clearly because I believe I still have like 6 more courses to go. That's my network acting. Aha. Data analysis in SQL. Let's see. So we still have accumulated like 1, 2, 3, 4, 5, 6. So we have like 6 courses to go. And statistics is under it here. So if I go back to the home dashboard, let me see the progress dashboard. What is this showing there? I want to see what that looks like. Can you do it, please? Is there an assessment? Day 44. If there's an assessment before moving to the next part of the course, let me see what the assessment looks like. So, assessments test your skills. Or you have two attempts. You get two attempts every 7 days to complete the assessments. So 15 questions, test your skills, data analysis, SQL, PostgreSQL, or time challenges. Solve a series of time challenges, 60 to 120 seconds before the timer runs out. Typically, it takes approximately 10 minutes. The assessment will automatically adapt to your skill level. Personal recommendation based on your score. That will be tomorrow. We'll do this tomorrow. Definitely part of what I'll do tomorrow. So we've been 1 hour into the live stream. Let's do that tomorrow before moving on to the next course, the next part of the course. So we've been consistent for the last, so I think this is the next to the assessment. So we've achieved today's daily goal 44. Yeah. So that will be the end of the live stream. So great. Alright, so thanks for joining my live stream. So if you found value in this video, please support the channel by hitting the subscribe button and give this video a thumbs up, and also put on the notification bell so you know every time I go live. Also check out my regular Excel videos. I'll be dropping more videos soon. It's not an easy day job, but we have to keep and be consistent. So thanks for joining. Don't forget to check out FCM under the YouTube description to produce FCM and become a successful freelancer also. And I'll see you on day 45 live stream. Peace out. Smash that subscribe button and